Hello everyone, myself Dr. Vivek Verma. Welcome back you all on our channel Statistical Hub. Today we are going to talk about the topic of one sample testing of hypothesis using R. This is in continuation of my earlier deliberation where we have explored the normality using the R software, and we have also checked how one can compare and can evaluate the normality assumption under the R interface. There are two different aspects of testing of hypothesis. One is called parametric, where the assumption and the characteristic of the parameter will take the leading role. And another interface of doing the testing of hypothesis is non-parametric way. In the parametric setup, the results that has been obtained is considering both normal as well as known non-normal distribution that will also capture if there is a variability among the group and is very much effective to achieve the statistical power. Whereas in the another counterpart of the parametric assumption, if the data is not following any known non-normal distributions and is comparatively small in size, or another situation may be that we want to explore the order data, rank data, or there is an outlier in the database. In that case, the non-parametric setup is considered as a more reliable. Let us consider a database that is composed of that most of the variable as a continuous variable. Here we have considered some of the characteristics, that is the patient ID is there, systolic blood pressure, diastolic blood pressure, total serum cholesterol, weight, height and body mass index. These are the standard clinical characteristics that will be considered to make a clinical decision or diagnosis plan. The first and topmost step that being any statistician wants to think of is to prepare the descriptive table so that one can understand what is the characteristic and distribution of the selected variable. Here we have depicted two different classifications if you are going to get the data summary in such a way that the first situation that mean is more than your standard deviation, and in another case that is mean is less than the standard deviation. If your mean is more than the standard deviation, the best measure to report that characterization of the database or the variable is to reporting that mean and their standard deviation. Whereas in situations where we have found that our mean is less than the standard deviation, the median, first quantile, third quantile and interquantile ranges that has been already explored in our previous deliberation can be considered as the best measure for the reporting. Now, what is the objective of the today's deliberation? The major part of that, if we want to understand the basic principle of testing of hypothesis, then we should build that particular realization in terms of understanding about our problem. If we are interested in doing the testing of hypothesis using the software R, which is freely available, then how one can proceed with, and one of the important component of that entire procedure is that if we want to pursue a particular parametric or non-parametric test, then how one can check the assumption of each of the testing procedure. If that is following a particular characteristics, then what should be the optimum and the most accurate way of analysis, and if it is not, then what is an alternative procedure which is available to us. In the last lecture we have talked about that how the normality assumption can be evaluated. Then the first and the very renowned and easiest way is to depict the distribution, data distribution. As I have depicted the two different structures, the first is approximately normal and the second is skewed one, and that is not talking about the normal, that is an other than the normal distribution. We are considering this as a non-normally distributed data. Okay, what we are going to talk about today, that is that the first topic we are going to emphasize in terms of utility of the normality assumption. If it is, then how the parametric test can be executed. The focus of the today's presentation is simple t-test, that is also known as independent t-test. If the data is not following the assumption of the parametric theory, then in that case the alternative way to evaluate our decision making procedure is using the non-parametric way, and the name of the test is Wilcoxon test for one sample. let's start about the one sample test. What do we mean by the one sample test? Let us consider a population which is composed of the human subjects, and our assumption is that the average age of the population is 50 years. Then the null hypothesis, which is not based on any kind of distributional or compositional assumption, we have considered as a null hypothesis and assume that our population mean age will be equal to 50. The most and broader spectrum of alternative hypothesis in contrast with the null hypothesis will be that our mean is not equal to 50. That says that the mean may be more than 50, maybe less than 50, but is not certainly going to equal to the 50 exact 50. Then in being any statistician, what one should think of, we are going to draw a sample from the population and we want to use that sample to check our assumption and to make a more accurate and decisive way to talk about the population characteristics. Now, what the sample will help? If we found that the sample mean, that is here we have considered as age, is closer to the assumed population mean age, then we should not reject our null hypothesis. Means we can say that we have the less evidence to reject our null hypothesis. If this if the sample mean is far away from the assumed population mean, then the null hypothesis should be rejected. Here rejection means that we are not have sufficient evidence to accept that the null hypothesis is conclusive. The question of concern here is how far can be considered as far enough to reject the null hypothesis. Then one of the important concepts that's run here is that critical value, that is a line on the sand for the decision making. What do we mean by the critical values? In the pictorial way, you can see that if the data is following a normal structure, then the critical value is nothing but is a cutoff, which says that if your obtained value, sample values, is less than that particular critical limit or more than that particular critical limit, then under this both of the assumption, we can't say that our sample mean is closer to the assumed population mean. While doing this procedure, there are two possible errors that can happen in the decision making. First is called type 1 error. In that situation, we reject the true null hypothesis about our population, and that is also considered as a serious type of error and usually denoted as alpha and is very much known as the level of significance that is predefined or pre-assured by the scholar or the researcher before doing the analysis. And the type 2 error is another type of error that occurs while doing the decision making. It happens when we are going to failure to reject the null hypothesis, which is false. That is usually denoted as beta, and 1 minus beta is known as the power of the test. Then based on the level of significance, what will the possible type of testing algorithm that is possible? If you just focus on the alternative hypothesis, your concept will be clear about what is the meaning of different types of test based on the assumption. If we are going to consider the null hypothesis that the mean age is equal to 50 and we are not sure about the direction of the population age, then we assume that the mean average age of the population is not equal to 50. Then the level of significance alpha will be split into two halves, that is alpha by 2 and alpha by 2. In both of the region, if our hypothesis or the obtained sample values is fall beyond that critical value, then that will be reject our null hypothesis of equality. Let us consider another situation. If our average mean, average age of the population is more than 50, that is called as the upper tail test. Means our concern is only about that higher ages above 50. On the contrary, if our concern is that most probably that the mean age will be less than 50, then that is called as a lower tail test. That is saying that when we are going to talk about the decision may be of three ways. This is two tail test, upper tail test, and the lower tail test. The interesting part for the entire discussion is that the decision about the type of test is based on the alternative hypothesis, not on the null hypothesis. The another serious problem with the testing of hypothesis when we are going to talk about the sample mean, that another characteristic of the population is called population standard deviation. If we are aware about the population standard deviation, then the Z test is very much known and is available, that is called, whose formula has been depicted here. Under the situation where the sigma is unknown quantity, then the T test is known as an alternative of a Z test. Here the degrees of freedom is saying that the number of total sample size minus number of parameters that are unknown. Here we have considered two parameters, that is mu and sigma, where S denotes the sample standard deviation as a substitute of the population standard deviation. Therefore, the degrees of freedom will be n minus 1. As an alternative of the parametric test, as we have talked about Z test and T test, if our data is non-normal probability distribution, or our mean is less than HD, then one should report the median as we have discussed in our previous slide. Then Wilcoxon test, which is a group of which belongs to the group of non-parametric test, should be considered as an alternative of our parametric setup. In order to demonstrate the feasibility and the evaluation procedure, we have considered the data of the National Family Health Survey 4, okay, that has been occurred in the year 2015-16 of the particular state, Delhi. The variable that I have considered for that presentation is that residence. Here 1 means rural, 2 means urban. Wealth may be of 5 categories: poorest, poor, middle, richer and richest. Gender 1 denotes the male and gender 2 denotes the female. And corresponding to each of the individual, the data has been collected for systolic blood pressure as well as the diastolic blood pressure. Now let's execute the entire setup using R. The first part of the doing any analysis using R is to import the data. Here we have stored the data in the CSV format, and the code for the import of the data has been read.csv and the destination folder which containing that particular CSV or the data set. As we have talked about, the first step to doing that analysis is to check the normality. Then the histogram is the best way to do so. The code has been depicted here, and we can see both the systolic and diastolic is looking closer to the normality. There are another ways. If we found that the skewness is closer to 0 or kurtosis is closer to 0, that will also say that the data is following the normality assumption. In the case of non-parametric setup, as we have discussed in our previous talk, that Shapiro-Wilkes test is very much famous for the normality. What we did here is that we are going to predict that whether in the case of gender male, in true sense, the systolic blood pressure is also following the normality or not. Then the p-value is saying that is very much smaller than that of 0.05. It says that it may be possible that as a whole the systolic blood pressure is following the normality assumption as we have seen in our depicted picture. But in case of male, that is not going to follow the normality, and that is very much following a non-normal distribution. In order to pursue a one sample t-test, the command is elaborated here as I have presented here, that alternative may be the two-sided, less than and greater than type, which I have explained in my previous slides. In the case we have started with mean mu, certain values which has been placed as a blank. If we are aware about the population characteristic, you should mention that one to check whether the sample is presenting the same population characteristics. Paired and another variable will be required for further analysis. One more important assumption is whether we are going to consider a homoscedasticity, whether it says that if there is a group level variability, then whether the variances can be considered as equal or not. The level of significance or the confidence level that we have considered as a 95%. The simplest command for execute the one sample t-test is t.test. Enter your column in which the continuous characteristic has been stored and your population defined mean. That is a very much required. as we all know that the systolic blood pressure, the known standard is 120, whereas the diastolic can be considered as 80 as a normal population. We have tried both of the things in the one sample t-test, and what we have found that, is it true that the population standard deviation is closer to population average systolic blood pressure is closer to 120 and diastolic blood pressure is closer to 80. The p-value is saying that even though the data is of that particular group, but none of them is closer to the value of standard population systolic blood pressure 120 and 80. That is significantly deviating from the 120 and 80 standard measure. In the reporting, we can also see that the 95% confidence interval of the data is also has been reported in the case of systolic blood pressure, that is 111.5 to 112.2, whereas in the diastolic that is varying from 65 to 75, and the average will be 75.43 in case of diastolic, and in case of systolic that is 111.9. What will happen if the data is not going to follow the normality distribution, and still we want to check whether our population mean is also attained by the sample map? Then the Wilcoxon test is for us, and the non-parametric setup, the command is very much easy. The same way the t-test will be replaced with the Wilcox test. But we have opted. We have seen that the value of p is still significantly lower than that of 0.05. It says that the population systolic blood pressure is significantly deviating from the population systolic blood pressure or the standard blood pressure, which we have considered as a normal as 120. It says that the population systolic blood pressure is not equals to that standard 120 normal systolic blood pressure. I hope you enjoyed that deliberation. If you found that these topics that has been explained is helpful for you, keep subscribing and following our channel. Have a great day.